Astronomers, including renowned physicist Brian Cox, are on high alert as the James Webb Space Telescope captures breathtaking images of Betelgeuse, one of the largest and most enigmatic stars in our galaxy. This colossal star, estimated to be around 764 times the size of our Sun, has been exhibiting unusual behavior that has sparked widespread concern and curiosity. The question that lingers in the minds of scientists and space enthusiasts alike is, when will Betelgeuse explode in a spectacular supernova, and what impact could it have on Earth? Betelgeuse, located in the constellation of Orion, has captivated stargazers for centuries. Ancient civilizations, including the Greeks and Babylonians, observed its distinctive reddish-orange hue and incorporated it into their celestial myths. It is the second brightest star in Orion and one of the most luminous objects in the night sky. However, in recent years, astronomers have detected extraordinary fluctuations in its brightness, leading to speculation about its impending fate. In late 2019, Betelgeuse underwent a dramatic event that left scientists puzzled. Its brightness suddenly, and unexpectedly diminished by nearly 60%, a phenomenon now referred to as the Great Dimming. Such an extreme drop in luminosity for a red supergiant was unprecedented. Initially, some astronomers feared that Betelgeuse was on the brink of a supernova, an explosion that would temporarily outshine an entire galaxy. Others suggested that the dimming might be due to massive amounts of dust expelled from the star's outer layers, partially obscuring its light. Subsequent observations using the Hubble Space Telescope and the Very Large Telescope in Chile revealed that Betelgeuse had indeed ejected an enormous cloud of gas and dust, blocking our view from Earth. This event was the largest mass ejection ever recorded from a star at this stage of its life. While Betelgeuse eventually regained its brightness in 2020, it did not return to its previous state. In fact, by 2023, astronomers noticed that it had become 150% brighter than before, fueling further speculation about its unpredictable behavior. This unusual activity suggests that Betelgeuse is experiencing extreme convective events beneath its surface. Some astronomers speculate that it might be going through the final stages before collapsing, but the precise timeline remains elusive. The sheer unpredictability of such massive stars keeps astronomers on the edge of their seats. To understand what's happening to Betelgeuse, we must first understand the life cycle of massive stars. Unlike our Sun, which has a stable and long-lasting nuclear reaction at its core, red supergiants like Betelgeuse burn through their fuel at an astonishing rate. With an estimated age of just 8 to 10 million years, Betelgeuse is already nearing the end of its short but dramatic lifespan. By contrast, our Sun is expected to burn for approximately 10 billion years. As a red supergiant, Betelgeuse has exhausted its supply of hydrogen, and is now fusing heavier elements in its core. Eventually, when it begins producing iron, the fusion process will become unsustainable, leading to a core collapse that triggers a cataclysmic supernova explosion. The question is not if, but when. Massive stars like Betelgeuse end their lives in spectacular fashion, and the aftermath of their destruction contributes to the formation of new stars and planetary systems. Supernovae enrich the cosmos with heavy elements like gold, silver, and uranium, playing a crucial role in the cosmic cycle of matter. In a way, Betelgeuse's eventual fate will contribute to the very building blocks of future celestial objects, including potentially habitable planets. The James Webb Space Telescope, JWST, has been instrumental in providing detailed observations of Betelgeuse. Equipped with advanced infrared capabilities, JWST can peer through cosmic dust clouds and analyze the star's outer layers with unparalleled clarity. Recent spectroscopic studies conducted by JWST have detected unusual light emissions, possibly indicating significant internal changes within Betelgeuse. In addition, ground-based observatories like ALMA, Atacama Large Millimeter/Submillimeter Array, in Chile have detected a massive plume of gas extending far from the star's surface, further confirming that Betelgeuse is shedding material at an accelerated rate. This is a strong indicator that it may be entering the final stages before a supernova event. When Betelgeuse does finally explode, it will be an event unlike anything seen in recorded human history. The explosion will be so powerful that it will briefly outshine the moon and be visible even in daylight for weeks, perhaps even months. During the night, the sky could be illuminated as if by a second sun. Although Betelgeuse is relatively close in cosmic terms, about 640 light-years from Earth, astronomers assure us that its supernova will not pose any direct threat to our planet. The explosion will release a massive amount of energy, including high-energy radiation such as gamma rays and X-rays. However, due to its distance, most of this radiation will dissipate before reaching Earth. One of the most fascinating consequences of a Betelgeuse supernova is the potential influx of neutrinos, tiny, nearly massless particles that rarely interact with matter. When a star collapses, it releases an enormous burst of neutrinos that can be detected by observatories on Earth. In fact, the first confirmed detection of neutrinos from a supernova occurred in 1987, when supernova 1987A exploded in the Large Magellanic Cloud. Scientists expect that Betelgeuse will provide another invaluable opportunity to study these elusive particles. Furthermore, the remnants of Betelgeuse's explosion will likely form either a neutron star or a black hole. If a neutron star is created, it would be one of the closest such objects to Earth, providing a unique opportunity for further study. If a black hole forms instead, it could give us insights into stellar collapse mechanics and gravitational physics. Brian Cox, a particle physicist and science communicator, has humorously remarked that Betelgeuse could go supernova tomorrow. While this is a light-hearted way of emphasizing its unpredictability, the reality is that tomorrow in astronomical terms could mean anywhere from a few months to 100,000 years. Because Betelgeuse is so massive and unstable, it is impossible to pinpoint the exact moment of its explosion. Another intriguing consideration is the time delay of light. Since Betelgeuse is 640 light-years away, any changes we observe today actually happened centuries ago. This means that Betelgeuse could have already exploded, and we simply haven't seen it yet because the light from the explosion has not reached us. While we cannot predict exactly when Betelgeuse will explode, scientists are closely monitoring every aspect of its behavior. The event will be one of the most significant celestial occurrences in modern history, offering a rare glimpse into the final moments of a massive star's life. Whether it explodes tomorrow or in the distant future, one thing is certain: it will be a sight to behold, an event that will be recorded in history as one of the most spectacular displays of cosmic power ever witnessed by humankind. Thank you for watching another episode of Discovery 2.0.